Hey all, welcome to Math 095. So the course starts with a review of factoring from 094. We're going to cover 6 sections, 5.1 through 5.6, or if you took it out of the first edition, it was 6.1 through 6.6. And so these first 5 sections are kind of each of the methods by themselves. If you are not strong at factoring, or it's been a while since you took the previous course, you should kind of go through these. The factoring is a really, really super important skill for what's coming up next at the beginning of 095, and we'll use it throughout the course. So this is kind of the one skill that if you're weak at will really, really come back to bite you kind of basically all throughout the next 10 weeks. So if you're weak at it, go through 5.1 through 5.5, which will be a bit of work, but you do need to know pretty much every single bit of it to do well on the first exam. If you're pretty strong at factoring, you just took 094, you did great on that last exam, maybe jump to the 5.6 video, and in that one I just do kind of one example of each style and then a bunch of matched problems. So if you just kind of need that light refresher, maybe don't do these first 5, just like I said, hop over to 5.6. Okay, so the first of our factoring methods, well, the first thing in factoring is, let me grab the flow chart. So there's this flow chart that goes with factoring. So is there a GCF? And so the first thing we learned in factoring is to look for a GCF. So that is this first problem. And I started to write up here, looking for a GCF, we got 81, 27, and 15. So what we're looking for is the biggest number that divides into all 3 of those. And so in terms of the numbers, an easy way to do that is to pick the least interesting number, which was 15. And 15 is 3 times 5. And so 5 doesn't go into 27 or 81, so that's why I have that one crossed out. I know it can't be that. 3 goes into 27 and it goes into 81, so that's going to be my greatest common factor for my coefficients. So I'll take a 3 out front. And then in terms of the variables, the letters, so those are actually really easy. You can take out the smallest power. And the reason is, if you think about, like, you can take 3x's out of 4x's, you'd have 1 left, right? But you can't take 4x's out of 3x's because you'd be like negative 1x, and that doesn't really make sense. So with the variables, it's the smallest power. So I have x to the first there, y, and y squared. So best I can do is y. So 3xy is my GCF, or greatest common factor. And then what would be left behind? 3 goes into 81 27 times. 1x out of 2 leaves an x. And I took the y out, so that'd be it. 3 into 27, that'd be 9. And so I'm going 3 times what will make 27. So that's the 3 into 27. And then xy already came out. And then 3 into 15, that'd be a 5. And then 1x and 1y would be left behind because I'm taking 1 each out. So that's an example of just a greatest common factor. The rest of 5.1 was about 4-term problems. And so if we get our factoring chart here, is there a GCF? Yes, factor it out. Okay, is it prime? So in this last example, what's left was prime, so I get to stop. Often it isn't, though. So then we count the number of terms. We can have 2, 3, or 4 terms. And right now we're looking at the 4-term problems, and those are always going to be 5.1 factored by grouping. And so factoring by grouping is where we cover up the second 2 terms, and we look and see what's common to the first 2. And we've already at that point scanned through and said, no, there's no GCF. So then I can just say cover up these 2. And notice they have a y in common, so I'll take a y out front, and it leaves an x plus 2. And then here's the thing with this, we got to get another x plus 2. It has to happen. Because what happens on the next line, if you remember, is this becomes our GCF, and we pull that out front. I like to write down the x plus 2 because it helps me get to the right thing. And so then I can kind of see, what do I multiply x by to get back to 3x? So here I'm just going to need a positive 3. And then this x plus 2, here and here, that's my GCF. So it's the same thing as if I had ya plus 3a. And if I took that a out front, it would be y plus 3. So that'd be factoring out the GCF. If I distribute back, I get this again. So this is of that same form, so I'm going to take the x plus 2 out front. So it's not that one of them is disappearing. It's just like this a here, I can represent it as factored out rather than multiplied into both of them. And then what's left behind is the y plus 3. So that's kind of how factoring by grouping works. Just a couple more examples to show a few iterations. This one, so I cover this up, and then I have an x in common in both those first two terms. So I'm going to go x out front and then y. And then I'm taking the x out, so I need a placeholder. And so we're going to use a 1 right there so that when I distribute back, I get the x. And then this one's kind of funky because I get, I'm supposed to get this again, right? Just like back up here. And that's exactly what I have. So again, it's another placeholder 1, but this time, since it's exactly what it's supposed to be, it's just going to be a positive 1. And so now there's my GCF. I pull it out front. And what's left behind is x plus 1. And you can kind of think of these, we're used to FOIL where we do first, outer, inner, last to FOIL things back. But you can think of this as a distribute, if that might make the grouping make a little more sense. If I think of x plus 2 times y and then x plus 2 times 3, just like it's a distribute, it's just I'm distributing the whole thing. X plus 2 times y, that's right there. X plus 2 times 3 is right there. So looking at this one, y minus 1 times x is here, and then I need that placeholder 1, y minus 1 times 1, so that I get the second piece back. Fourth problem, so this time we have a cube, and we got to be aware of cubes because sometimes they factor further. So in this case, I can take out an x squared from those two because that's my smallest power. So x squared, and then x plus 6 is left behind. Again, I like to write down the x plus 6. And then that helps me see I need to factor out a negative 4. A lot of times what students will do is they'll take out a negative off of they'll look at this and write down negative 4x, and then write down negative 6. And you see what happened with the signs? That's where they got messed up, and then these don't match. So we don't want to do that. That's why I like to write down what it is I have to get, which is the same thing as I have here, and then make that happen. So now if you check my signs, negative 4x is cool, negative 4 times 6 also cool, negative 24. So I could take out my x plus 6, and then that leaves behind that x squared minus 4. And so here's where I got to jump forward a little bit, because hopefully in 95 you have learned factoring. And so this should look familiar as one of those difference of squares that we're going to see reviewed in 5.4 when I get there. But for now, I'll kind of remind you, when you have a squared minus b squared, it's a plus b, a minus b. And so hopefully you guys know that. And if not, you'll see it when we get to 5.4. But usually, a minus b. There we go. So x plus 2, x minus 2. Hopefully that's familiar. Okay, so these next 4 matched problems, the ones I just did, they're the ones that have you guys try in class. And so I'll go through these a little quicker. First one's going to be a GCF problem, 20, 12, and 4. So 4 goes into everything. I have x to the 4th, 3rd, and 2nd. So that's going to be x squared out front. And y cubed, y squared, y to the 1st. So always the smallest power. So that's going to be a y. So here 4 goes into 25 times, or 4 times 5 gets me back to 20. I'm taking 2 x's out of 4 x's, so that's going to leave x squared. 1 y out of 3 y's, so it'll be y squared. 4 goes into 12 3 times. 2 x's out of 3 makes x. Y out of y squared makes y. And then here, I'm taking a 4 out of a negative 4, so that's going to leave a negative 1. And x squared and y are already taken out. Number 6, let's see, so we've got a cube, so we got to be a little careful, see what happens. So I can take an x squared out of those first 2. So x minus 5. And as I say that about the cube, it's because if it's a cube, it has the potential to factor 3 times. If it's a square, it will only factor 2 times. So here I need another x minus 5. And to make that happen, so this is a nice place to use this little trick. It helps you see you need to take out a negative 6, and then negative 6x is good. Negative 6 times negative 5 makes that positive 30. So that's why I like to write that down, because it makes me do usually a better job of getting the sign right here. There's my GCF. X minus 5 comes out front, and then x squared minus 6 left behind. So this one isn't going to factor further, and that's because this isn't a perfect square. So remember our formula, a squared minus b squared, a plus b, a minus b. Only good when b is a perfect square. So we're not going to do any kind of crazy x plus root 6, x minus root 6. That's a little bit later in the course, but for now we would just leave that. This one right here, the first two terms, I could do a 2 and a y. So that's going to be 2y out front, and it's going to leave behind a 3x plus 1. And then that's exactly what I have here. So we'll say plus 1, 3x plus 1. That one's just kind of my placeholder. And there's the GCF. So that comes out front. And then 2y plus 1. And I keep saying it comes out front, but that's just because that's how I think of it, as factoring it out. The order we write these in doesn't matter at all. So if you have them the other direction, same exact answer. And let's see, number 8, out of those first two, I can do a 4x squared. So we'll do that, and then that leaves me x minus 1. Here, I can take out a negative 9, and that's another x minus 1. And then I can take out an x minus 1 as the GCF, and then that's going to leave behind 4x squared minus 9. So now this one does have perfect squares on the ends like I have up here, and so this is one of those sneaky ones where I have to remember our 5.4, and that's going to go 2x plus 3, 2x minus 3. If you don't remember that, like I said, it's okay, we'll catch it in 5.4.